Hi, this is Premjit from civilera.com. I just thought of discussing one doubt a student asked me today, and the question was about releasing moments at both the ends of a beam. So here the student has marked as well that the bending moment is coming like this and it's different when it is not released. So can I do this is the question from the student. Now let me first sketch and show you what the exact question is. So now say you have a building like this and say you have a column in this manner. I'm just sketching an example. It could be something different. The idea is to convey our doubt and the question. Yeah. So what she is asking is, say I have a secondary beam here like this. Yeah. So this is your primary beam. 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 And this is the red color one is your secondary beam. So the question is, can I release the moment here and here? Okay, so before telling you the answer, let me sketch the bending moment diagram of this particular secondary beam. Now, why is it a secondary beam? Those who don't know that can refer to one of my blog. I think I have mentioned it there. I will direct you to that later. Now, the bending moment diagram is supposed to be like this if you don't release any moment. Now 1 2 3, something like this. So this should be something like this. The bending moment diagram is something like this. It is going to be, if you check in your ETABS, this will be a very minor moment, something like 4 or something like that. Yeah, so that is how it is going to be. Now, can you release that, and should you release that? In my honest opinion, you shouldn't be releasing these moments at all. Now, to understand that, let us discuss what is a simply supported beam. Now this, if you have a wall here and a wall here, and if you have a slab or a beam resting like this, you have all the 6 degrees of freedom free here. It is not restrained at all, only that it cannot come down because of gravity, because your wall is supporting that. So this is what is called as simply supported beam. Now this can move in all the directions, it can rotate as well, and you will have a zero moment and WL square by 8. This is your simply supported condition. Now the moment you have any kind of restraint here which will not allow this to move, which will restrain, that is a restraint. It is not a fully fixed condition. It necessarily need not be a fully fixed condition, but it's a restrained condition if you have anything. So in our case, you have a beam supporting a beam, something like this. Yeah. Now what will happen? Say it's a one span beam. Assume that this is a one span beam. Let us not consider the continuity at the moment. What will happen if you release? Now this is restrained. It is not simply supported, because you have some kind of restraint because of the stiffness of the beam and the beam connectivity. Could be slab as well. So it will not be 0. It will be something like that. This will be slightly less than WL square by 8. This will be slightly more than 0. So this will be your real situation. Now for this, how do you detail at site? You detail something like this. Yeah, so this beam bar is generally going to be bent down. Yeah, you may not give LD, you may give LD. It all depends on what is the detail that you want to achieve. So now this is the real condition. So if you detail, this is right, the moments are right, whatever moment you get, you design for that, you get whatever steel is needed, well and good. Now if you look at your textbooks, or if you look at some engineers practice, what they do is they release this end moment and this end moment, especially when you are doing it by hand. And what happens, your moment becomes this WL square by 8, WL square by 8 at the span and 0 at the ends. So now you are making it simply supported by force, in the sense you are redistributing the moment, whatever moment coming here for whatever. Yeah, so here if you see it was less than wl square by 8, you are passing on that moment onto the span and making it behave like a simply supported beam. Now you can say that okay, I will detail it specially. Okay, I will do only a straight bar here or a little bend here. I'm not going to let it develop full moment. So I can consider it as I can consider it as zero simply supported condition. Not really. Yeah, it will work, but strictly speaking, uh, it is not needed to do in that manner. You need not release the moment and make it simply supported. That is a way many engineers deal that. It's fine if you don't do a development link there, that is fine to do it, but it's not needed either. My opinion is that leave it to the model, because the real stiffness is coming into play and you get the real moment over there. And more interestingly, here you are giving anyway 212. You are not giving a detail without a bar there. You are never going to give only bottom steel. You are always going to have 212 at the top. Yeah, now if you release this moment, there is a good chance that this steel, if you need 212, might slightly become more and you may have to give 216. So now why do you want to do that? Because anyway you have 212 at the top, and that 212 can definitely take that moment 4 or 10 or whatever. 212 has a good capacity. You can back work and calculate it, and it will be much higher than the actual end moment that you are going to get there. So why to release? There is no real need for releasing it, but in case if you want to do it, ensure that you don't develop the moment there, detail it to suit. But still I feel it is okay to detail with the moment that you get there. You need not release that. That's my opinion. There may be engineers who have a difference of opinion, but this is my opinion there. Now coming to the question, this is a continuous beam. Now continuous beam, as I said, this is the moment. Now if you release the moment at both ends, it becomes like this. Now inside, can you achieve this? The answer is a big no, because your beam is going to be something like this. Yeah, now your rebars are straight at the top. Whatever you do, your connection here, you cannot release because your bars are continuous across that joint. You can never easily make this discontinuous. Nobody is going to detail something like cut bars here with a little uh, gap. You are not going to do that detail at all. So you cannot achieve. Even if you do that, you'll crack up. So you never do that. So you cannot release at the continuous support. You cannot achieve that inside really. So you cannot do that. So releasing the moment at the continuous support is a strict no. You can't do it in RC beam structures. Yeah, here again at either of the ends, maybe you can do it. Again, as I said, it is not needed, but some engineers do practice that. So if you really want, you can do it. So what happens, the moment will redistribute and come to the span, and the span moments will slightly increase. So in real projects, in reality, your continuous edges cannot be released. Your end edges, maybe you can, but it is not essential. I don't recommend you release. You go with what you get. No need of releasing these moments. Now sometimes when you have steel structures, your steel structural members are connected, and if this connection is a pinned connection between the continuous, even when you have a continuous beam, it's not generally continuous across the support. You have cut beams which are being pinned into the the steel columns. So steel beams, steel columns, you are having a pinned connection at the column beam junctions. If that is your case, if again it's a fixed connection, you cannot do it. If it's a pinned connection, then yes, you can consider that to be simply supported. It is simply supported, so definitely you have to release the moments. So if it's a steel structure with steel beams which aren't continuous and which are pinned at the column, you can definitely release the mz off. Mz means instead it is mz, in etaps it is m3. You have bending moment, the mean moment is m3 in etaps if you have rightly modeled. Instead it would be mz. So that's all about releasing moments in a beam.